Good afternoon, everyone, and welcome to a Nortal Learning Hive event. As you all probably know, we have a special guest today, Jon Skeet, who is probably most known from the Stack Overflow, having answered over 35,000 questions. And he's also a Google staff engineer and an active blogger and an author of C# in-depth book, which is already in its 4th edition. So today, Jon is going to share some advice on working with date times. And I believe that all of you who have worked in international software projects have learned that date times over multiple time zones can be surprisingly tricky. Before handing over to Jon, all microphones should be muted during the presentation, but there is a Q&A section available in Teams if you have any questions about the topic. And please do ask. Jon and I will keep an eye on the questions during the presentation, and there will be an open Q&A at the end of the presentation to get some discussion going on. And the open Q&A is really if you want to ask something different than dates and times related. So that's your chance. So without further ado, please welcome Jon Skeet.
Hi everyone, I'm hoping that you can all see my presentation. I'm being told by Teams every so often that that the network quality is poor, so I'm hoping that won't actually cause a problem. However, you can see that I've started the presentation not with dates and times at all, but with asking people to be kind. This is not a mistake. You're not in the wrong presentation, or I'm not in the wrong presentation. But just to give a bit of background, I was at a Caribbean developer conference, which was lovely a few years ago, and I was giving one of the keynotes, and I realized while I was preparing the presentation in fact on the flight over to the Caribbean, that I didn't really want any slides. I wanted to just talk and people think as they were listening rather than reading the bullet points on a slide. And the conference organizer greeted me at the airport, and I was saying, it's okay if I don't have any slides. And he said, yep, that's fine. So what, should we just put a big picture of your head and contact details? It's like, no, that's a terrible idea. Why on earth would anyone want to see my head? Yeah, it's bad enough you've got to see me in person without a giant version of me. No, why don't you just put be kind? And I had a slide like this one, and I've started putting them at the start and end of most of my presentations, because if you go away from this presentation, and act a little bit more kindly. I'm in no way suggesting that anyone on this call isn't kind already, but I think just a little nudge in that direction to remind people, hey, when things have gone wrong, don't take it out on other people, whatever it is. I would rather be able to nudge people into being kind than being able to help you with dates and times. If it's one or the other, then being kind will save the world more than being good with dates and times. That's all I'll say, but just it's something I like to nudge people with. So actual dates and times. The point of today's presentation is really to encourage you to think about dates and times more when you're working with them. Some people take the attitude that it all just works fine. I don't need to think too much about it. And they end up with problems in their code because you do need to think it's a relatively complex topic. On the other hand, some other people think, oh, it's so complex, I'm never going to get my head around it. Nothing will ever work correctly, so I won't worry about it too much and just hope. And again, you end up with some broken code. So I would like us to steer into a middle ground where we're not too afraid of dates and times, but you're aware of some of the potential problems, and you have the tool set to think through things. So a little background of this talk is that most of us have code that deals with dates and times, and a large proportion of it is wrong. Maybe just subtly wrong, may only be for 2 hours per year. And I suspect that some of you who've already faced outages or problems due to daylight saving time know exactly which 2 hours I'm talking about. But the main message is that this is manageable. I started thinking about dates and times when I was working on Google Mobile Sync, which was my starter project when I was a new Googler. And that was around the same time that Stack Overflow started, and Stack Overflow had a Dev Days set of conferences, which I presented at, and presented this sort of 20-minute, half an hour talk on the way that humanity has messed up computing in terms of numbers and text and dates and times. And that was also the start of the Noda Time project, because one of my main messages in that talk was use the right tool for the job, which at the time for Java was Noda Time, and for .NET I had to say, well, there isn't anything. So I then started the Noda Time project, which I will refer to at various points in this, and that sort of led me into thinking about dates and times a lot more, and hopefully having a coherent way of presenting the whole topic. So the broad spectrum of this talk is I will go through a bunch of the concepts in the talk, in the area of dates and times, and you might be surprised at just how many there are, particularly if you come from the old school Java, where there was Java util date and Java util calendar, and that was kind of it. And Java util time zone, and the .NET world, where we started with just date time, then we got date time offset and time zone info. It's like, well, that's 3 types in each of those languages. Is that enough? And my answer is no. And hopefully by explaining the different concepts, I'll give you, as I said, tools in your tool belt to think about things. To be clear, whatever platform you're using, there will be some reasonable date and time libraries, some not so good, and you may not get a choice. If you're using .NET, you may not be able to use Noda Time. I think you would be better off if you use Noda Time, but if you've got the right tools up here, it doesn't matter if you've got the right tools at the keyboard. You can decide to document everything using a clear set of concepts and name your variables appropriately, and it doesn't matter hugely. It's annoying, but it's not infeasible if you use the same set of concepts and document what you mean, even if the type system doesn't help you much. So our first concept is an instant. This is an instant in time. So this feels like it's in terms of machine time. So imagine a world where there aren't any people. So no one needs to really care, no one's doing farming. So what difference does a year make? Seasons don't matter to machines. The idea of a month or even a day doesn't matter to a machine. It doesn't care whether it's night or not. It just has an instant in time. And the way that I tend to think about describing this is, if you're on a phone call with someone, and imagine we have infinitely fast phone lines, you could click your fingers and the other person would say, yep, I heard that at instant X, and you would agree on what instant in time that click happened. You may have different wristwatch versions. I might think, for me, it's just coming up to 12:15. I gather for many of you, it's coming up to 2:15. So we can disagree on what our local idea of the time is, but we could agree on the instant in time that it was. And the way that that's usually represented is in terms of some fixed point in time that everyone agrees on to start with. So that's called an epoch, and how long it's been since then. And we'll go into that, how long it's been, in a bit more detail later on. So natural examples of instants are things like timestamps. So if you've got a log entry, that happened at an instant in time. Likewise, commit timestamps. Anything that comes with a timestamp, which is when something happened, that's a good candidate to be an instant in time that different people can view in different ways. And unless it really mattered where it happened, only the instant is particularly relevant. And importantly, 2 instants in time, even if they happen in different places, there's a fixed ordering between them. You can say this happened before that happened, even if in local times it would be the other way around. So machine time deals with instants. We then have calendar systems, and this is where humans come in. So humans like dealing with years and months and days and things because it makes our lives easier. It would have been really hard to schedule this Teams call if we'd had to say, well, we'll do it at 13,400,205. That's when it's going to occur. Like, well, I can't keep track of when that is compared with, when I was having dinner yesterday. It would be too annoying. So we've broken time down into things that make sense to us, which are years, because years are useful. They're a natural, regularly occurring thing that makes an impact on people's lives, less than it used to. But when you were farming, it would make a huge difference. You would design what you did around the time of year. Now, it might change what food we have available and whether we want to go on holiday or not, but it's not sort of the be all and end all, which it used to be. So that's one natural sort of time boundary. And the other that really does affect us all is the day. So roughly 24 hours, and we all go to sleep roughly once a day. You would rarely find someone who was working on a 26-hour day, for example. I'm sure that some astronauts sort of train in that particular way, but a day is a natural thing. And having a month between that, maybe we could have had 10 months instead of 12. Some calendars do have 13 months, for example, or even 19 in one example I could give you. But months are a little bit more, well, it would be annoying to have to talk about day 213. It's much more useful to be able to talk about September the 15th or whatever that day would have been. So it just breaks things up. Roughly equivalent to a lunar cycle, so how long the moon takes to go from new moon to new moon. But even that, 28 days versus 31 days, it's not an exact match. So I tend to think that months were more just convenient. Now, of course, the month systems that we've got and Gregorian dates that most of us are used to are a little bit odd. We've got leap years to work out, but it kind of makes sense for the most part. So that's what a calendar is. There are several different calendar systems. So the Gregorian calendar is the one that we tend to know best, but there are various Islamic calendars, Japanese calendars. The Hebrew calendar system is really interesting. There's the Wanderer's calendar system for the Baha'i faith. I do find it interesting how it's all related to religion. I would suggest that dates and times are where religion impacts computing most. The Gregorian calendar that we're used to isn't what people have been using, even if they've been talking about January, February, etc. for hundreds of years. There used to be a calendar system called the Julian calendar system, which was a bit simpler in terms of its leap year rule, but that would have had a bit of a skew over time. Over thousands of years, we'd end up with June being in the middle of winter in the Northern Hemisphere. So that's why we moved to the Gregorian calendar system, and that happened at different times at different places in the world, which just makes things really, really confusing. You probably in your software won't need to deal with different calendar systems, but it's worth knowing that they exist. Okay, so going from a calendar system, we've got a calendar system and we've got a time of day. That means I can say that right now for me, my local date and time is 12:19 on November 27th, 2020. Okay, that's a concept that it's local to me. I haven't provided enough context to sort of ground it in anything else. Just a local date and time doesn't tell you the instant in time that it refers to. So 2 hours ago, Aki, for example, would also have experienced 12:19 on the 27th of November, etc. And the way that things come into focus there is with time zones. Now, I've only just become aware that the version of the presentation I'm doing, I have several different PowerPoints here, doesn't have all the pictures that I do have somewhere, but I'm hoping that this makes enough sense as it is with just the words to focus on. But a time zone is complicated, but fundamentally I would say a time zone consists of three things. There's an identifier, its name. How are you going to say I'm in this time zone? And that may well not be what you expect it to be. We'll come back to that. So an identifier, a region of the Earth that it covers, and the idea is that in that region of the Earth, which could be sort of the eastern part of the United States or some subset of the eastern part of the United States or the whole of the United Kingdom, whatever it is, everyone there will observe the same local date and time. Their wristwatches, if they're correct, will all be set to the same thing throughout history, past and future. And you can decide to simplify things a bit and say, well, we don't care about time zones, about different regions that, you know, in the end of the 19th century used to observe different local times. We'll say we only care about time zones being the same since 1970 or whatever it is. But the idea is everything at any instant in time, everyone in that time zone would show the same local date and time. And it is, so that's the region of the Earth, and it's also the mapping from instant to local date and time. And it's important to understand that it's in that direction, from instant to local date and time. That is an unambiguous conversion. So at any instant in time, I can say the local time in the Europe/London time zone, which is the one I'm in, is that particular, you know, the result of that mapping. That mapping isn't unambiguous in the reverse direction. And anyone who has worked with time zones that have daylight saving times or have changed, you know, some time zones change what their standard time is every so often, will know where I'm coming from here, that if we fall back, so turn our clocks back an hour, going from summertime to wintertime, then suddenly we're observing the same local dates and times again. So I can't remember when it was, but we fell back on something like October the 26th in the UK. So 2 AM became 1 AM, which meant that, for example, 20 past 1 in the morning on that date happened twice. So if I only said to someone, I'll meet you at 20 past 1 in the morning on this particular date, then for most dates, that's fine. For this particular date, you could both have been at the right place at 20 past 1 and not meet each other, because one of you could have thought, well, it's the earlier 20 past 1, and one of you could have thought it's the later 20 past 1, because it happens twice. So the mapping from local time to back to instant can be ambiguous. It can also be skipped entirely. So back in March or April, whenever we moved the clocks forward, we skipped from 1 o'clock to 2 o'clock. So then if you'd said to someone, I'll meet you at 20 past 1, they'd have said, well, that doesn't exist. You've given me a meeting that makes no sense. So again, a local date and time in a particular time zone will map to usually 1, but occasionally 0 or 2 different instants in time. So that's time zones. We'll come back to some of the difficult aspects of time zones, but if you understand that fundamental bit, then hopefully the rest sort of comes fairly naturally. Okay, next we have durations and periods. For some reason I can't, there we go. So I said earlier how an instant in time we tended to represent as an epoch, So that's some fixed time, which, for example, would be January the 1st at midnight UTC, where UTC is a sort of pseudo time zone, in 1970. That's the Unix epoch, and everything's measured from then. So a Unix time would be the number of seconds that have occurred since that epoch. And that idea of the number of seconds that have occurred, or the number of nanoseconds, that's generalizable into it's a duration of time. Importantly, it definitely can't contain months. A month, 3 months, or 1 year, those are not durations because they depend on what year you're talking about. You know, the year 2004 is longer than the year 2005 because it's a leap year. So you can't say how many seconds are in that particular year without, or sorry, you can't say how many seconds are in a year without knowing which year we're talking about. But a duration is back in that feeling of machine time. A duration is a fixed number of nanoseconds, seconds, microseconds, something that can be measured by a machine without reference to any kind of calendar system. Now compare that with a period. I mentioned a year, or maybe 1 year, 6 months, 2 days and 5 hours. That is what's called a period. And even though something like 5 hours could be either a duration or a period, the main difference is that a duration can only use these sort of fixed known units, whereas a period can use things like years. And a period is what you use with calendar systems to do calendar arithmetic. So if you want to ask how old someone is in terms of years, then firstly you need to know which calendar system they're talking about, because strangely enough, you could be different ages in different calendar systems, even if they're trying to be roughly 365 days in each year. It wouldn't be terribly hard to have two people who differed in age, one in the Julian system and one in the Gregorian calendar system, and far more likely to be that in something like the Hebrew calendar system, where when there's a leap year in the Hebrew calendar system, there are 13 months instead of 12. So those differ much more in terms of length, and you can get into oddities with that. Calendar arithmetic is tricky in general because it doesn't obey the rules that you would like it to. So, for example, what happens if you add 2 months to January the no, let's stick with 1 month, adding 1 month to January the 30th, 2005. Okay, so there are two kind of obvious answers and there's no strictly correct one. You could say, well, that's past the end of February, so I'll call it March the 1st. So January 30th, 2005, add a month. You could say you go to March the 1st, or you could say I'll just truncate to the end of February and you've got February the 28th, 2005. I'm saying the year because if you do the same thing with 2004, you could still get March the 1st, or you could get February the 29th, 2004. But either way, with any of those answers, if you subtract 1 month from that answer, what do you get? Well, if you decided that the result of the addition was March the 1st, then what's March the 1st subtract 1 month? Presumably February the 1st. What's February the 28th subtracting a month? January the 28th, not January 30th. Even if you had February the 29th because you were in 2004, adding a month to January 30th and then subtracting a month, you'd end up with potentially January 29th instead of January 30th. So you can't reverse things just by adding a period and then subtracting it. Likewise, depending on exactly what your system does, taking a starting date, adding a period and adding the same period again or a different period might get you a different result to taking the date and adding period 1 plus period 2. For example, suppose we take our nice example of January 30th, 2005. We're going to add a month and then add another month. we can say, okay, that's easy. We'll add 1 month and get to February the 28th, 2005, and then add another month and we'll get to March the 28th, 2005. That was doing one period at a time. Whereas I think we can all, there can be some subtleties with adding periods together, but I think we could all agree that adding 1 month to 1 month should give you 2 months. So what happens if we add 2 months to January 30th, 2005? We get to March 30th, 2005, not March 28th. So, date plus period isn't the same as date plus period. And that's even while we're within one calendar system. The fact that you get adding a month to a date, if you've got the same day that we're all referring to as different dates in different calendar systems, if you add 1 month in each of those calendar systems, you could end up being in radically different days. So if you're having a meeting with someone and say, right, I'll see you the same date next month, even if you don't have any of this truncation because February's short or whatever, you could end up trying to meet on radically different days. So calendar arithmetic is difficult. And let's go into some of the other problems and myths around date and time things. I'm just aware, by the way, I'm checking on the Q&A every so often, and so far I'm not seeing any questions. Please, if anything I'm saying doesn't make much sense or you want to dig into something, then do just ask. Otherwise, I'm very aware that you're just listening to my voice the whole time. At least I hope you are. Aki seems to be sort of able to hear me. He seems to be puzzled when I'd expect him to be puzzled. So I'm assuming that everyone can actually still hear me. So the problems and myths to do with dates and times. The first suggestion is that you should think. When I've developed the Noda Time library for .NET, I've taken a slightly different approach to many other libraries. Lots of other libraries say, oh, don't make me think, don't make the developer think about things, just do the right thing. And the trouble is that in dates and times, if you're not careful, the right thing can be really ambiguous if you aren't absolutely precise about what you mean. Here's an example. Suppose you say, we're going to have an election. You can vote if you are 18 years old or more on the date of the election itself. That sounds great. And you hold an election in 2022 on the 28th of February. Could someone who was born on February the 29th in 2004 vote in that election? And that depends on how you do the arithmetic and how you decide that birthdays work. If you say, I will subtract 18 years from the election date, which, just to remind you, was 28th of February in 2022. If you subtract 18 years from that, that's relatively easy. You get to February the 28th in 2004. So you could say that's an easy way. Anyone who was born on February the 28th, 2004 or earlier, that's fine. They will be able to vote. So that person born on February 29th could not vote. On the other hand, if you say, I will add 18 years to the person's date of birth, and if the result is on or before the election date, then they can vote. You say, okay, February 29th, 2004, add 18 years. Well, the result could be February 28th, 2022, or March 1st, 2022. So you've got to make the decision there. But if you say, I'm going to truncate, that's a reasonable thing to do. I think most people who were born on February 29th, I think most people celebrate their birthday on February 28th. So they can vote. So you get different results, and being able to vote or not really matters. And none of the options that I've given you there, either subtracting 18 years or adding 18 years but rolling forward, or adding 18 years and truncating, those are all entirely reasonable positions to have, and someone might assume that's what you mean if you say anyone who was born 18 years ago or anyone who is 18 years old. If you don't define what you mean, then you can end up miscommunicating with someone. So be really prepared anytime you see anything in a requirements document around dates and times, particularly if it's doing any arithmetic on it. Say, I'm sorry, product manager, I know this is going to sound really nitpicky, but we really need to know exactly what you mean by if they're 18 years old. Is there a law that says exactly what this means? If not, let's at least define what we think it means and make that really clear in the specification. Hopefully, once you've done that, you can code that relatively easily. I find that the hard bits of dates and times aren't doing the coding in most cases. It's doing the specifying. So that's where being able to communicate with people really, really clearly in documents, have loads of examples and they'll form your unit tests, that kind of thing, really, really important. Okay, next up, DateTime.now should not exist. I don't know how many people on the call are .NET developers versus Java developers, etc. But there are two big reasons. No, three reasons why DateTime.now is a bad thing. Right. Firstly, it's static. That means that you are naturally writing untestable code when you use DateTime.now. It's really hard to test things that call into a static property or a static method because you can't fake them out any easy way. I'll come on to a way of avoiding that in a minute. It's also a property. Now, properties, the fact that you can fetch this property twice in quick succession and it may or may not have changed its value without anything telling it to change its value is at least slightly messy. Properties are meant to feel a bit like fields. It's a bit weird. So if it had been datetime.getCurrentTime as a method, that would make me feel very slightly better. And I should say in Noda Time 1, our abstraction for getting the current time did use a property, and it was a mistake, and I fixed it in Noda Time 2 by making it a method instead. It's a breaking change that I didn't take lightly, but I thought, no, I want to actually get this right. Thirdly, DateTime.now does something implicitly that I would like you to always be explicit about. It's using the system local time zone. Now, sometimes that is entirely reasonable. If you are telling the user of the same machine, this is when something happened. You know, I'm writing log entries on the screen, and so you know that the user is in the same time zone as the system, assuming everything's been set up correctly. Using the system local time zone is reasonable. It's almost never the right thing to do on a server. It shouldn't matter. How your program runs should not depend on which place a server is located in. That defeats half the point of being a server. The idea is it's remote. It shouldn't care where it is. So those are the three reasons for not using DateTime.now. You can't test it. It's a property when it sort of shouldn't be, and it's implicitly using this default. DateTime.utc now doesn't have that last problem, does still have the first two problems. So the first of those problems is the lack of testability. And this is where I really like the abstraction of a clock. So in Noda Time, this is an iClock interface. And if you're not using Noda Time, don't let that put you off. You can write your own iClock interface so easily. You know, I could almost edit the slide deck in front of you to show you what it is. It's literally a single method of get current instant that returns a date time offset or a date time, whichever it is, but it returns the UTC one of whatever you're talking about so that the local time zone isn't relevant. So single method interface that has a method rather than a property, and the method is defined to return the UTC instant in time. And as soon as you've got that interface, you use dependency injection in exactly the same way that you do everywhere else that you're requesting a service. Getting the current time is a service, just as being able to find a user is a service. And as soon as you start thinking about it in that way, rather than something you can call at statically, then all kinds of things make more sense. In Noda Time, we have the idea of a zoned clock. So the clock itself does not know anything about time zones, but we have, I think it's called wall clock, a zoned clock, that's it, where you say, I would like a clock that is in a particular time zone. And then, because you've said I want it to be in a particular time zone, it makes sense to say, hey, what's the current date, or what's the current date and time in this particular time zone, or even as a local date and time. I haven't explained some of when I was going through the concepts earlier on, that was a subset of the number of types you would see in Noda Time. I'll reel them off later on, but there are a lot of types, and a zoned clock can make some of that make more sense. But if you're doing all of this for yourself in .NET, you need the interface, you need a class called system clock that has a singleton instance. So system clock implements iClock by returning datetime offset.utc now, or whatever it is. Datetime.utc now if you want to use datetime, but it's really easy. Singleton instance, but you would still refer to iClock everywhere within your code. And then you have a fake clock that is also really simple. If you don't need it to do anything fancy, you can have like literally 5 lines of code. So public class fake clock implements iClock. Fake clock accepts a date time in the constructor and remembers it, and then returns that whenever you ask for it. And then just through those 3 tiny types, your code can be testable. So now if you want to know what's going to happen in the next leap year and check that your code does the right thing, you can do so. If you want to check that if the user is in a particular time zone and you're dealing with an instant which is ambiguous, so it's 1:20 in the morning happens twice, and you can check that by seeing what happens the first time and what happens the second time. It's all great. It's all so testable as soon as you've just injected things in. I would strongly urge you to avoid ambiguity in your code wherever possible. Datetime is a really annoying type for this. Again, this is really aimed at .NET folks. If you're not dealing with .NET, then Java util date is also terrible. Use java.time, etc. But datetime refers to either a local date and time that is known to be in the current system time zone, an unspecified date time, which is like local date time earlier on that we were talking about, which is, well, it's 12:17 somewhere, but we don't know where, which is a perfectly fine concept, but it's not the same as it being in the system local time zone. Or a date time can be, this is UTC, which is also a perfectly fine concept, but it's the fact that date time puts all 3 of those together is just really difficult. Because then when you get past a date time in your method, whatever the method is meant to do, you need to think, oh, I've got to check for all these, either you say it must be a UTC date time, or it must be an unspecified unspecified date time, etc. And you have to write some checking code, or you have to define what it does for all of those 3 kinds. So try to be really specific for any piece of information. You really should know whether it's going to be UTC, going to be in an unspecified time zone, maybe with a time zone field separately, or whether it is system local, which, as I say, is almost never a good idea. So avoid that kind of ambiguity. Anyone reading your code should know what to expect and should know which of those flavors you're actually getting. So it's a little bit like, imagine we only had a number type, just like JavaScript does really, and some of the time you're expecting it to be an integer, and some of the time you're expecting, no, it could be a non-integer. Well, as .NET developers, we like having integers of different sizes and various floating point types. Date and times work in exactly the same way. So where you would say this must be an integer, say this must be a UTC date time, which is effectively an instant in time. As soon as you can make all that clearer, and that should obviously feed down from your spec into the code, then you're getting rid of this whole class of misunderstandings and miscommunications. Next one's really important, and this really goes out to all the project managers out there. Limit the scope of what you need to do. So I haven't even mentioned leap seconds, and that's kind of deliberate. I honestly, I don't understand them properly. I try every so often, but it sort of makes very little sense to me. Leap seconds, there are multiple timelines that are sort of the same apart from leap seconds, and leap seconds are added into, or not yet, but in theory they could be removed from the timeline. So suddenly you get a minute that lasts 61 seconds instead of 60 seconds, and you get a bit of warning that this is going to happen, but it makes all kinds of things really, really hard to work with, violates all of your assumptions. Most business code doesn't need to know about this. If you're writing an NTP server or client, or if you're dealing with GPS, you do need to know about this kind of thing, but most business software doesn't. Likewise, most business software doesn't need to care about relativity. That everything I've said so far makes very little sense if you need to care about relativity. The idea that you could have instants in time that you could agree on, well, that sort of falls apart a bit if you have to deal with relativity. Most businesses don't need to deal with, well, I have one customer traveling at half the speed of light and another is stationary. And they're, of course, both traveling at half the speed of light compared with each other. It makes my head hurt. I'm sure it would make your head hurt as well. Just say no. You probably, and this is more dubious, you probably don't need to deal with any calendar system other than the Gregorian calendar system. If you are writing a calendar, like if you're writing Google Calendar, you absolutely need to care about this. If you're writing tax software that is available in a country that uses a calendar other than the Gregorian calendar, you need to support that calendar, because you need to be able to say, well, your taxes are due on this day of this month, and you can't necessarily just say that in terms of Gregorian calendars. Even if you do need to support non-Gregorian calendars, you probably don't need to support historical weirdnesses. So in 1712, in Sweden, they had February the 30th for weird reasons of trying to go from the Julian calendar system to the Gregorian. I think that the range of business software that needs to support February the 30th in 1712, that's a real niche market. If you do need to support that, make sure they're paying you big bucks for it, because it's going to cause all kinds of weirdness. So limit the scope to only things you do need to care about. Now we're going to start talking about some problems with time zones. And this is where things are going to get a bit ugly. But the first thing to do is avoid time zone abbreviations. So CST, if you have colleagues in the US, say in Chicago, I think Chicago observes Central Time. CST can mean a lot of different things to different people. It's not a time zone. It is sort of half a time zone. So I observe in the UK, I flit between GMT, Greenwich Mean Time, and BST, which is British Summertime. If I'd been alive in 1970, that would have been during British Standard Time, which was also UTC +1, but slightly differently to British Summertime being UTC +1. None of these are time zones. They're really annoying. It's okay to display them, but you should never ask for them. Because as soon as someone says, I'm in CST, it's like, well, that doesn't, for one thing, I'm not sure I believe you. So someone could, I see this all the time. Someone says, oh, can we meet on June 30th at 10 p.m. PST? And I have to say, well, do you mean PST, or are you using PST as a shorthand for Pacific Time, which is at that point in Pacific Daylight Time, PDT? Because if you mean Pacific Standard Time, PST, then I need to know that. Otherwise, I'm going to be there at the wrong time. So people will say PST and all these other abbreviations without meaning what they're saying, and what they're saying doesn't identify a time zone. So just say no, basically. The next thing, and this is a biggie that I can already half feel people saying, no, that's not a myth, that does work. I've used that before and it works fine. This myth that you should take the user input, which is in a particular time zone, convert it to UTC, that is then unambiguous. You can use UTC everywhere and all will be fine. And it's very appealing. It's appealing in the same way that I would agree, take what the user has said, which is in as a string, convert that string into a date and time, the appropriate date and time type, use that type for as long as you can, and then format it when you need to. Don't deal with the string all over the place. Don't start sending strings in your SQL queries and getting things back as strings. There's a good reason to use types. Unfortunately, that slightly falls apart when it comes to this just store UTC. Let's go through an example. So suppose we had, and I suppose I should update this slide every couple of years to make it slightly into the future. Suppose you're writing an event planning system, and in 2018, a user says, I would like to book a meeting at 9 o'clock in the morning on December the 1st, 2019 in Paris. And the system looks at the time zone rules and says, aha, I know when 9 a.m. in Paris on December the 1st, 2019 is. It's 8 a.m. UTC on the same date. So you then store that in the database. Suppose the French government had changed, and this may well be coming up in next year or the year after or whenever it is, says, OK, we're going to abolish daylight saving time for France. We're going into permanent summertime UTC +2 from October 2019. Okay, it's entirely feasible that would happen. And this is the time zone rules changing. This happens multiple times a year across the world, and the time zone databases all get sort of distributed in different ways, which is kind of tricky in itself. But you need to be aware that the rules can change. And thank you, Clydas. I've just seen that you've got a question there. I will come to that in just a minute when I finish this example. So you need to be aware that the rules can change in the future. They probably won't change in the past, although it's entirely possible that a government has said, right, well, we're abolishing daylight saving time from tomorrow, and tomorrow comes, your software is still running, it doesn't have the new rules yet. So you might still sometimes see things in the past changing what they mean, but it's relatively rare, whereas things changing in the future is entirely feasible. So we've stored 8 o'clock UTC. The user says in, say, November 2019, right, show me when I've got meetings, and we take that UTC value and convert it back again. And we expect to get what the user originally said, but we don't. We get 10 o'clock instead of 9 o'clock. So the mistake here was assuming that we could reverse converting the user's time zoned version, 9 a.m. in Paris, to UTC and back again without losing information. There are two reasons it could lose information. One is, okay, 9 o'clock, it's probably going to be okay. If this had been 20 past 1 in the morning, well, I've already given you several examples where either 20 past 1 might not exist or 20 past 1 existed twice. And you need to know what your system should do in those terms via specifications. Product managers, again, you need to be working on this. But the other thing is the rules changing, and lots of people will think about the first one and think, okay, well, I will deal with that once and once only, and that's fine. Store it in UTC and it'll come back to the right thing. They don't imagine the rules can ever change. The right way of doing things, from my perspective, in my view, is to store what the user told you. If you store the user's input, and maybe you validate it and say, okay, well, I will check that that time exists just once, exactly once, and assume that that much stays true later on. And it could be that you're wrong about that, and that actually the time zone rules change so that 9 o'clock in the morning happens twice. You know, it's unlikely, but you need to be aware of that and figure it out. But at least you still know what the user originally told you. If you only store UTC, or even if you store UTC and a time zone, you don't know what the user told you. You know, I'm storing the UTC value that I thought would be the case when the user told me. You could store the time zone and the version of the time zone information that you were using, at which point, yes, it is reversible, other than the ambiguity side of things. But then in order to convert from one set of time zone information to another, you have to have both available, do the reversing so that you get back to what the user told you, and then apply your conversion back to UTC again. Well, if you're going to have to know what the user told you anyway, why not just store that? And this is a golden rule across multiple things. If you store exactly what the user says, then if you're wrong about any of your supposedly lossless conversions, later on, you can always go back to them and say, right, this is what you said. I now understand it to mean something slightly different. Okay, I'm going to have a look at the question. So Clyde says, if there are so many problems with date and time in Java/.NET, why are these suggested improvements not implemented in the languages as default? Breaking changes could be solved in various ways. Great question. So I should start by saying Java and .NET are the environments I know best, but this is a problem in all languages, all platforms. Java is actually probably kind of leading the field in that Java.time is much better than Java util date and Java util calendar. It's the best baked in date and time system that I know of at the moment. JavaScript is getting a better one. It may have already been approved, I'm not sure. A friend of mine called Maggie was driving that, and you get something a little bit more like Noda Time. I'm not sure that it has different calendar systems and things, but you get a much better set of types to work in JavaScript. In .NET, well, trying to change, you can't make date time unambiguous when it's been ambiguous for all the time. Various people have asked Microsoft to basically do something like Noda Time. And I'm not saying Noda Time is perfect, but it's better than date time. Do something like Noda Time in the .NET framework itself, or they could just say, do you know what, we suggest that you start using Noda Time in the same way that many people started saying, just start using Joda Time. Unfortunately, there are all kinds of tricky bits in terms of serialization and how are you going to interact with databases, and there's just a huge amount of code using DateTime out there. None of this is to dissuade you from using a better library, but once you've been wrong for so long, it's quite hard to get right. So yeah, in Java, they decided we're going to fully go with this in Java.time, and that was a good thing to do, I think. I hope that sort of answers your question, Clyde. Alar has asked, are there any conceptual or philosophical differences between Noda Time and Joda Time? Yes, there are. So Noda Time started, the history of this, I started by porting Joda Time, and initially I ported the sort of underlying engine, the bit that did all the tricky parts. I ported that fairly closely, but thought I'll put a public API surface, and I kept all of that internal, where in Joda Time there's a lot that's public, and that makes me very nervous. Keep that internal and redesign the public API. So there are a bunch of places in Joda Time that will use the system local time zone by default. If you pass null in as a time zone, it says, yeah, that's fine, I'll just use the system local time zone. I wanted to avoid defaults everywhere. And oh, the other thing, I think you can do something like new instant, and it will say, oh, you didn't specify when you mean, I will just consult the system clock. Both of these things use things implicitly, and I wanted everything to be as explicit as possible. So you don't, nothing uses the system clock unless you tell it to. There's one tiny discrepancy there. If we're trying to work out what time zone you mean and we can't quite do so for various reasons, we'll look at the 5 years before and after the current time, but that's the only place that we implicitly use the system clock. And I don't think we ever use the system default time zone by default. So that's a philosophical difference. There are various things that Joda Time allows you to do that I think don't make very much sense. I can't remember many of the details there offhand. Because .NET has value types and things like instant are clearly natural value types, that immediately stops some of the complexity that you get in Joda Time, where the inheritance hierarchy is like 7 levels deep sometimes. And I think that that's just a bad thing in terms of maintainability and understanding what things do. They have the idea of Joda Time has immutable types and mutable types that both implement the same interface, and that ends up being quite tricky to handle as well. So there are some things there, but there's a lot that we have in common between Joda Time and Noda Time, certainly. Having originally ported the Joda Time engine, I then completely rewrote the engine without rewriting the front end, as it were, the API surface. So now internally they look very, very, very different. But still, I would never deny that Noda Time owes an awful lot to Joda Time in terms of its history and how it got to where it is. I hope that answers the question well. Okay, I have 2 more slides and then we can go to more open Q&A. So to summarize, it's really important to understand that you definitely can get things right. I hope I've inspired you all to take the rest of your Friday afternoon to look at everywhere that you're doing date and time code, date and time work in your code, and think, is that what I meant? Can I make that clearer? Can I make it more testable by injecting a clock? All this sort of thing. Really, the clarity is the main goal. If something is broken but clear, easy to fix. If it's correct but really unclear, then it's hard to ever modify, and sometime you will need to modify it. Just inject a clock. This hopefully really easy thing to do. Everywhere that you are statically finding out the current date and time, think, how can I avoid doing that? Try not to generalize too much in terms of the answer to a problem in one place may not be the same as the answer to the same question in a different context. So it's fine to have, you could have product-wide rules of every time I'm going to make something depend on how old someone is, I will compute that in the same way. That kind of consistency is great, but don't always assume that just because you've used instant in one place that you should use instant everywhere, because sometimes it will be a user-driven thing and sometimes it will be machine-driven, and that should suggest whether it's an instant or a zone date and time and things. Restrict your scope as far as possible, get rid of leap seconds, etc. If you don't need to use time zones, then don't. That will simplify things significantly. Avoid time zone abbreviations, I've been over, and again, converting everything to UTC makes it feel like you've avoided all time zone problems, but you haven't. It's a relatively corner case thing for rules to change after between when you store something and when you need it, but it's not so corner casey that you shouldn't think about it. If you search for storing UTC is not a silver bullet, you'll find a blog post where I go into a lot more detail. And finally, going back to my be kind idea, be kind with people who disagree with you. If you disagree with me about storing UTC, I hope we can have a conversation about it. There's no need for either of us to say that the other person is stupid just because they disagree, or anything like that. This probably is more important now than when I first created this slide a couple of years ago. We seem to be more and more engaged in assuming that people who disagree with us are morally bankrupt for whatever reason. Let's try to get get some more unity instead of division. I'm going to stop presenting now. That doesn't mean I'm stopping anything else. I can see there's another question in terms of how do I see the future of dates and times after someone starts to live on Mars? It's a great question, a really difficult one. I hope it will be a long time before business software needs to care about this, because trying to handle Martian dates and Earth dates in the same software is going to be really hard. Particularly, imagine you're trying to schedule a meeting. If I remember rightly, a Martian day is about 28 hours long, and an Earth day is obviously 24. You get, now I think I was looking at this just yesterday, I think it's Pluto or possibly Jupiter, where the day is about 10 hours long. So that's tricky. On Venus, it's about 116 Earth days for one Venetian day, and a Venetian day is longer than a Venetian year, if you can get your head around that. So the day is through the planet turning with respect to the sun, so which bit of the planet is closest to the sun at any time, whereas the year is how often it goes around, the planet goes around the sun. And on Venus, for one thing, the planet spins a different way to how Earth spins, and it spins on its own axis less often than it goes around the sun. So if you imagine being in a meeting and say, see you at the same time tomorrow, well, you're not going to see the person who's on Venus for another 117 Earth days. I hope to have retired before this becomes a problem, but maybe I will tinker with Noda Time in my retirement. Noda Time version 9 or whatever will suddenly support non-terrestrial days. It's not going to be fun though. And with that, any other questions?
Brilliant. Thank you, Jon. I wanted to ask you about the date times and especially persistence of date times. That are there like really rule of thumbs that in business applications, how would you usually store dates and times in database?
So different databases, I've been really disappointed with how unclear databases are in their documentation. I think most databases have a timestamp type or something like it. So anytime you're storing an instant, that's a good candidate to use a timestamp. If you're not storing an instant, this is where the converting to UTC comes in. If it's in the past, then maybe convert it to UTC and store a timestamp. Otherwise, hopefully the database has something that represents what I call a civil date and time, local date and time, and store it that way. But if you care about the time zone, and maybe you don't, maybe you just want to say, the user asked to be woken up at 9 o'clock in the morning, and that's a general 9 o'clock in the morning, store that as just a time of day. But if it is meant to be something like our meeting in Paris, 1st of December 2019 at 9 AM, then I would suggest storing that local version, the time zone ID, ideally the IANA time zone, so the Internet Assignment of Numbers and Addresses. I can't remember exactly what it's called, but IANA runs the time zone database that is the big one that everything apart from Windows uses, and I would suggest using IANA time zone IDs, so something like Europe/Paris, so that's the time zone ID. You might want to store what version of time zone data was I using when I saw this. You may not need to, it's kind of up to you, but it does make it easier because you also want to potentially store the UTC version, not on its own. This is derived data. This should never be seen as golden source of truth data. But if you store the UTC version, then if you know that the time zone database has changed, you could do that conversion from local to UTC again and just overwrite all the UTC data because it's just derived data. And having that derived data, having the UTC, gives you a total ordering. So you can say this meeting happens before that meeting. And you can do that really efficiently in the database because you've done the conversion once. Whereas if one meeting is in France and another is in Germany, then in order to check which one happens first, you potentially need to do the time zone conversions all the time. And interestingly, if the rules change, the UTC value of one of them may change without the UTC value of the other changing. So you could have a meeting that's scheduled for in a year's time. And right now, I think that meeting A will happen before meeting B, but because of rule changes, actually meeting B happens before meeting A. That becomes clearer that you need to think about that if you've got that derived data and you're using that derived data to present a calendar view or whatever, and you think, oh, well, I know that the rules have changed, so I will reapply that. And I might need to tell users, hey, you may see some changes because of this kind of thing. So I look at what your database can store and then work out, make sure that you've always got the real source of truth, what the user told you, and anything else you can derive. I have no problem with deriving a UTC timestamp. Just remember that it's derived. We've got another few questions, several questions in the chat. Seem can see that I'm passionate about dates and times, but is curious as to why. And that's really having worked on Google Mobile Sync. That got me into it, partly because I experienced a load of the problems. I was using Noda Time and I did some things wrong. So as an example, I came in one day in September, I think it was, probably about 2009, and found hundreds of thousands of exceptions in my logs because Brazil had its daylight saving time change, and that happens at midnight. It skips from midnight till 1 o'clock. And so my code was still somewhere saying, oh, please tell me midnight on this date. And Noda Time was saying, doesn't exist, mate. Can't do it. I have made the mistake of assuming that midnight happened everywhere, or at least at 12 o'clock. How do you define midnight? Some people will say it's 12 o'clock in the morning. Some people will say it's when one date changes to the other. And those sound like they're the same thing until you're in Brazil or a similar time zone. So I started getting interested in that, and then I did this presentation to Stack Overflow Dev Days and realized, oh, .NET doesn't really have a good date and time library. I should probably do something about that. And as soon as you're building a date and time library, you find out all these interesting things, and it's such a fascinating topic. I haven't got into half the trivia that I have with weird stuff that's happened over the years. I just find it a fascinating topic, and one that I'm aware we can do better at as an industry. And so, I'm hopefully making our industry very, very slightly better, both through code and through doing talks like this. And that's probably, in terms of technical things, one of the best impacts I can have on the technical industry. So yeah, that's why I'm passionate about it. Moving on, is there any progress on official-ish Noda Time support for Entity Framework Core with a SQL Server provider? So NPG SQL supports Noda Time already. I have no plans to do this because this is an area that I don't know anything about. So it's never going to be official as in from the Noda Time authors, unless the Noda Time authors expands beyond the 2 or 3 of us that are currently involved. That said, I would hope that someone could build an Entity Framework Core plugin in whatever form it's called that will handle this. I seem to remember that its custom value type handling has been improving. I don't know whether it's enough or not. Look at what's available on NuGet. If you think it's feasible and no one's done it, even though I wouldn't write the code myself, I'm very, very, very happy to help answer any questions about how should I represent this in Noda Time, or how should I represent this Noda Time concept in SQL Server, or whatever it is. Happy to help as best I can. It's just not something that I'll want to be maintaining myself over time. But great question. Any famous business failures or stories caused by incorrect handling of dates and times? There have been various outages caused by leap seconds, or I think Azure has had several outages due to February the 29th being incorrectly deemed not a leap year or a leap year, depending on the year. And it's a bit of a shame that that's still happening. And maybe it's not happening for Azure anymore, but it happened more recently than you might have expected. I don't have any particularly amusing stories beyond, yeah, that kind of sucks. Next question, what about birth dates? When someone will be born in November 28th in 2020, part of our planet will still be living in 2020, November 27th. Will they have a negative age? So, you might want to represent two different things. You might want to care about the date on which they were born and store it just as a date, or you might care about the instant in which they were born, in which case, yes, and at a given instant, you can say someone is so many seconds old. You won't know whether it's how many days or years old, because that will depend on where you are and which time zone and calendar system you're using. But think about what you care about. You might want to record the instant and the time zone they were in, which will give you the local time. And you can't just record the local time without and time zone without also recording the offset in case it's ambiguous. You know, I've got two babies. One was born at 1:15 in the morning. One was born at 1:20 in the morning. Is one 5 minutes older than the other? No, one's 65 minutes older than the other, or no, one's 55 minutes older than the other. It can go any of those three ways. So, you know, you need to think about being reasonably precise about that, but think about what you really care about. So I suspect that for most legal reasons, the date on which you were born in the time zone in which you were born is the important bit. So I was born in the UK, which means my birthday happens here before it happens in New York. But my guess is if I became a US citizen and the voting age was raised to 44 or 50 odd or whatever, whenever it becomes relevant, I suspect that the date of my birth would still be the important bit, even though I might not be old enough to vote. If you looked at the current time in where I was born, etc. I think most people just care about the date. But yeah, that's exactly that question, even though my answer ends up being quite simple of you probably just want to store the date. That kind of question is exactly what you should be asking yourself when you decide to use a birth date somewhere in your application. What do I actually care about? What am I going to do with this information? How might time zones and things affect it? Great question. All good questions. I'm just going to take a bit of water while we're in a breather between questions. Oh, right, I see three more. So in my opinion, should Java util date be deprecated and not used in any new project? It being actually marked as deprecated might not be a great idea, just because if people have warnings as errors, it could cause some problems. But I would certainly personally consider it as deprecated. You might find that you need to interact with it you might have to call into an API that only accepts Java util date. And I would basically try to use Java.time for as far as you possibly can. If you need to use that API in many places, then wrap it in your own API that is written in terms of Java.time and just shims passing in Java util date. I would try to avoid using it as far as is humanly possible. Absolutely. Have I read the Jon Skeet facts? Absolutely. I've contributed a couple of them myself. My favorite one is probably, this was back before C#5 had come out, was that I'd already written the version of C# in depth for C#5, and the language designers were going to only be able to open it when they'd finished, so they could see whether they designed C#5 correctly. Which, knowing Mads Torgerson quite well, tickles me. He's a very, very, very smart cookie and a lovely person as well. Next, should I celebrate or report my birthday at file location, which effectively changes the date of my birth in another day in that location? This goes back to the previous thing in terms of when you celebrate. You can celebrate your birthday whenever you like. If you try to celebrate it several times a year, then the people celebrating it with you and giving you presents might start objecting. But who am I to say when you should celebrate something? I would generally say that most people choose to, and most legal documents, I suspect, use the date in the place that you were born, and would probably consider what that date would be in the calendar system that you're now talking about. So most of the time we're all going to be using the Gregorian calendar system. If I were using the Hebrew calendar system and talking to a Jewish friend of mine as to saying, when are you celebrating your birthday, it might make sense for me to convert my birth date in the UK to a Hebrew calendar system date still from the time zone of the UK, and talk about it in those terms. And so you could celebrate your birthday several different times a year by saying, well, today's my Jewish birthday, today's my Hindi birthday, today's my Gregorian calendar system birthday, today's my Islamic birthday. You could have different birthdays in that sense. Be context aware, basically.
Yeah, I have one more.
Okay.
EU is planning to getting rid of daylight saving time, and I'm not sure whether UK will follow, but in terms of logistics, and do you think that will be viable to actually do, or will it cause a mess?
I actually submitted evidence to the House of Lords committee that was discussing this, which anyone could do, by the way. It's not that the House of Lords came to me or anything, but I think it's entirely possible. I suspect that the EU will do it. I suspect it may cause some confusion. I really, really hope that if it happens, firstly, the EU gives enough notice. I would say at least 6 months, ideally more than a year of notice, so that we can all make sure our software will do things correctly. Secondly, I really hope the UK follows suit, which will make it tricky. I work with the US quite a lot, working for a US company. For about 4 weeks a year, my time zone is either 9 hours ahead or 7 hours ahead of Pacific time. Most of the time it's 8 hours, so that would have to change, and most of the time I'd be 8 hours for half the year, 7 hours for about half the year, I think, maybe 9 hours for about half the year, and there'd be some oddities around things flipping when the US flipped. But I really hope that what I really hope doesn't happen is that people who are really keen on Brexit, which I have to say I was not, again, going back to my slide, if we disagree, then let's be kind with each other. But I hope that we won't get to the position where people say, well, Brexit happened so that we can go our own path. Therefore, the EU's making the decision in one direction. We must therefore make it in the opposite direction, and we shall not, we'll keep going just because the EU's stopping, or vice versa. I really hope that doesn't work. The EU's our closest trading partner, and I'm sure will be whatever happens with the trade deal that's being talked about. So it makes sense for me. I hope that the whole of the EU goes or doesn't go. Having it vary across the EU would be very difficult, and I hope that the UK takes the same decision. I won't say follows the EU, but takes the same decision that the EU does.
Brilliant, thank you. Okay. Looks like we are out of questions. Anyone? Any questions? Yeah, looks like we are not getting any questions. Well,
Right.
thank you, John. It was really interesting, really brilliant
Good,
stuff.
I'm
So
glad.
thank you for
My pleasure. My pleasure. Right. In which case, thank you very much for hosting me, and let's do this again sometime.
Yeah, thank you very much, and have a great weekend, everyone.
Thank you. Yes,
Thank
all of you.
Cheers. Bye.
Bye then.